All right, geometry friends, let's do this. Okay, I have had a lot of questions, guys, a lot of questions on this vocabulary piece and your angle pairs. And so this is my not so subtle message to you. If you have not already finished your vocabulary on pages 40 and 41 from your workbook, you need to do that and memorize the names of your angle pairs. Okay, so I don't know if that means making some flashcards or, you know, doing a little extra on the side like that. One thing I will share with you is this idea of corresponding angles. I think is one of the harder angle pairs to understand. So I'm just going to highlight a corresponding angle here. So angle 2, if you think of taking this angle for angle 2, and I'm not quite sure how I could maybe just drag it down the line. But if you think of taking it and moving it backwards down here to angle 6, those are corresponding angles. And on the assignment that you were working on Schoology, it does matter if you spelled the words correctly. So I would refer to your workbook pages if you are having trouble with memorizing the spelling. Okay, so those are corresponding angles. That was one that is a little bit tricky. Another one that is a little bit tricky is this idea of a linear pair. So a linear pair is going to happen anywhere a pair of angles comes together along a line. So essentially they're going to share, they're going to share a line, this pair of angles, and they're always going to be supplementary. So angle 6 and angle 8 are a linear pair, and there are a variety of other linear pairs around this diagram. Okay. So memorizing those angle pairs and knowing those is going to be really important for your success in this section. And then a reminder that we did talk about there are basically 2 ways to set up your angle pair relationships. When lines are parallel, either you're going to have angles that are congruent to each other, like these corresponding angles you see here in question number 5, or you could have an angle plus another angle, and that's not going to be an example of one of those kind. I thought I had one of each, but I don't. Another example could be where you have a couple of angles that are going to be equal to 180 degrees. For example, if you knew, for example, angle 6 right here was 3x, and angle 4 was, I don't know, 7x plus 10, let's say. Okay, so in a problem like this where you have same side interior angles, and you can see you have one small angle and one big angle. So you can tell just by looking at the picture that one is acute and one is obtuse. So you have one of each. The setup for a problem like that is going to be that you add together those 2 angles and set them equal to 180 and continue to solve from there. So that would be 10x plus 10 is equal to 180. We'd subtract our 10 from both sides, do our algebra, divide by 10, and get x is equal to 17. Okay, so that's one way to set things up. The other way to set things up is if you know 2 angles are equal to each other. So in this problem right here, actually in both of these 2 examples, you're dealing with corresponding angles. So you would set up 72 is equal to 13x plus 7. Okay, and then you would go about solving, subtracting 7, dividing by your 13, and getting your x is equal to, I think that's 5. Okay. Over on this side, same idea. See how it's a big angle? And sliding down that transversal, you have another big angle, an obtuse angle for each. So we're going to say 12x plus 15. is equal to 135. And we'll move through the algebra of this fairly quickly so we can get on to our next problem. Dividing by 12, we get x equals 10. Now, please do remember that sometimes it will ask you to use this value of x equals 10 or x equals 5 and plug it back in to solve for a measurement of an angle. So if it does ask you to do that, just be mindful of that situation. Okay. The last example I have for you here for this particular video is a situation where we're working backwards. Okay, so this time we don't know already that A is parallel to B. Usually that is given, okay? But in this little small proof that we're going to do right here, we don't know yet that A is parallel to B, okay? But what happens is angle 10 is congruent to angle 9. Those are alternate exterior angles. It gives me the measure of angle 5. It gives me the measure of angle 3. And we talked in class about how that would be listed as given information. Okay, so that's information we know. Now, the fact that angle 10 and angle 9 are actually congruent means that we can say that A is parallel to B, and that is because of what's called the converse, and we'll talk in class about the idea of a converse and a conditional statement. That's the converse of alternate exterior angles. Okay, and I'm running out of space over here, so I'm gonna give us a little more room. Okay, so because I do now know that lines A and B are parallel, then what I can say about 5 and 3, here they are, 5 and 3, those are alternate sides inside the parallel lines across the transversal. So I can say the measure of angle 5 must equal the measure of angle 3. And that's by alternate interior angles. Okay, so if I know that and I can substitute 5x plus 4 in for the measure of angle 5, and I can substitute 6x minus 16 in for the measure of angle 3, that's called substitution when I put those in for each other, I can continue to solve with an algebraic process. And each of those steps has a reason. Okay, so I'm going to go ahead and I'm going to add 16 to both sides. And that has a reason as well. It's called the addition property of equality. So we'll say addition property of equality. We're going to kind of summarize that with a little shorthand. We end up with 5x plus 20 is equal to 6x. If I subtract 5x from each side, guess what that's called? That's called the subtraction property of equality. And you have just conducted a proof. See, this is what we were trying to get at right here. We were trying to get to this little x is equal to 20, and there it is. We did it. We showed that x was equal to 20 in this problem. So we'll practice some more problems like this. Just another example of how you can use kind of that step-by-step statement reasoning to develop an argument for a mathematical problem. All right, guys, there you go. Have a good rest of your day.